Hi, welcome to my channel. In this video, we are going to learn about ARM Cortex-M core architecture. So let's go into the first. The first thing I want to show you is what is inside a microcontroller. As you can see, there are many components built up in microcontroller, like this one. Normally we divided them into two parts. The first is CPU. This one is CPU. It is ARM Cortex-M 0 plus, and the second is various peripheral like this. It is the rest of the microcontroller. So microcontroller is integrated by processor and various different peripherals like this. If we call microcontrollers based on ARM, which means that processor use the ARM architecture. In this series, we only focus on ARM Cortex-M core CPU. There are many different types of ARM Cortex, such as ARM Cortex-A architecture, ARM Cortex-M core. We only focus in ARM Cortex-M because it is particularly designed for microcontroller, right? So ARM Cortex-M core is a group of 32 bits RISC processor core. What is RISC? RISC stands for Reduced Instruction Set Computer. That means a set of instruction is reduced, optimized for low cost and energy. It's a target for the microcontroller. So next, we will explore how those manufacturers design their own microcontroller. Let me explain in a simplest way. This one is a microcontroller architecture. When a manufacturer designs their own microcontroller, first they are going to receive the ARM mainline processor. This one is ARM processor, and here is ARM mainline core. It will be written in Verilog language, right? And then they have the ability to choose custom design by performing architecture and adding optimization and further extension. This one, there are some extensions of the ARM Cortex-M processor. For example, adding NVIC for interrupt management, system timer, MPU is memory protection unit, APU for floating point calculation, children and children security. CR in these blocks we call them is silicon options. This component in this block is optional design that depends on the manufacturers. Here is silicon option. Select CPU combined with various peripherals. They are adding some peripherals like timers, like flash memories, RAM memories, oscillator, watchdog timer, some connectivities like SPI, I2C, CAN, etc. We call them is peripherals. Microcontroller adding them to finish their design, and the last the CPU connect with the peripherals via system bus. This one is system bus to communicate and transfer data with them. Right, that's very straightforward. This is the microcontroller architecture. So to determine which silicon option have been included in a particular ARM CPU, please refer to manufacturer datasheet and related documentation to know more detail about the architecture of the processor. that the manufacturer design. ARM silicon options are not limited to specific Cortex-M core, but are designed to support a range of ARM core, allowing for flexible and customizable microcontroller design. That means uh, ARM silicon option is not for a specific core, but a range of core, right? For example, Cortex-M 0 does not support data table offset register. You can see this table uh, with a data table offset register is not supported by Cortex-M0, and from Cortex-M0 Plus to MSD5 that supports the data table offset register. You can refer to this link to get more detail of ARM Cortex-M optional components. ARM v6M, v7M, and v8M are different versions, or you can understand a generation of ARM architecture. You can call as version 6, 7, and version 8. In fact, with increasing of IoT device, makes the embedded system risk, which can be easily compromised by cyber attacks. So, with the MES version, ARM Trust Technologies is an optional security extension designed to provide improved system security in a wide for embedded applications. That means with M version S that supports ARM Trust Technology, ARM Trust Technologies is a security feature to provide hardware isolation and processor. That means creating true execution environment inside a processor. I will explain more detail in the next section. So next is Cortex-M variant or Cortex-M families. I divide two parts. First is visual security and optional security. With visual security, we have ARM v6M and ARM v7M. With ARM v6 or ARM version 6 is there are Cortex-M0, Cortex-M0 Plus, and 01. With Cortex version 7, we have Cortex-M3, Cortex-M4, and Cortex-M7. So next is optional securities. Optional security we have M23, Cortex-M33, 35B, Cortex-M52, 55, and 85. All of them called as ARM v8M. This one is all of variants of Cortex-M core. Okay, the next section is RA4E1 based on ARM Cortex-M33. We exploit the CPU of RA4E1. You can see this one is RA4E1 architecture microcontroller, with the rest block is the ARM Cortex-M33. This one is includes the DSP digital signal processing, APU floating point unit, IDAU belong to security threshold. We will explore later. APU memory protection unit, and which nested vector interrupt controller for interrupt management, CC timer, and debug interface. Okay, I will sum up by the architecture of RA4E1 microcontroller that we are using in this series. With the more about them, we will step by step explore in a lot of next video in my series. If you have a question, leave a comment below of this video. If my videos is helpful for you, please give me a thumbs up and subscribe to my channel. Thank you and see you in the next video.